Hey everyone, welcome to my poster. Please don't hesitate to email me if you have any questions or just want to chat some more about our findings. But really briefly, the work I'll be presenting will be a summary of a project that focused on examining the effect of repeated retrievals on the neural support for autobiographical remembering. So, when we remember a past personal experience, this involves bringing together the various details associated with that experience. In other words, retrieving autobiographical memories requires these constructive episodic processes that allow us to bring together different detailed components associated with an event. So, things like who was there, what happened, where the event took place, etc., to ultimately reconstruct a mental representation of that event and allow us to consciously re experience it in our minds. So, this reconstructive process relies on activity across a distributed network of primarily left lateralized brain regions, among which, of course, is the hippocampus, and in particular the anterior hippocampus, that is known to play an especially important role in associating together the relevant event details to support the construction and the retrieval of an autobiographical memory. Now, there's some compelling evidence from work done on other mental construction tasks, so like future imagination tasks, that suggest that the constructive demands of a task can change as a function of rehearsal and subsequently affect how the brain supports that task. And so, the primary objective of this project was to examine how changing the constructive demands of an autobiographical memory retrieval task will affect the brain, or more specifically, the hypothesis we were interested in testing was that repeated retrievals of a memory are going to reduce the episodic constructive processes necessary to remember a past experience, and that this will be reflected in the patterns of neural activity that we observe. So, to test this, we invited 24 young adults to recollect autobiographical memories while undergoing an fMRI scan. But before doing so, participants first completed a pre-scan autobiographical memory questionnaire where they listed a bunch of their autobiographical memories and rated them on a number of ratings, so things like importance, vividness, etc. And then from this questionnaire, we selected 6 recent and 6 remote memories that were rated equally in terms of the ratings that we collected. And then we used these memories as personalized cues for our in-scanner task. For our in-scanner autobiographical memory task, participants were shown the event titles of those pre-selected memories and were instructed to silently think of all the details associated with that event for 8 seconds. And critically, each memory was remembered 4 times throughout the experiment, and this is what allowed us to address our main question, which was this question of how the repeated retrievals of the same autobiographical memory can change how the brain supports remembering that memory. And so to answer this, we took 2 analytic approaches. So first, we began our analyses by taking a region of interest approach focused on the hippocampus. Now, given the critical role that the hippocampus plays in memory construction, we predicted that any effect of repetition on the constructive processes engaged to support remembering should be particularly evident in this region. And so for our analyses, we extracted beta weights, which we can think of as an index of neural activity, from the anterior and posterior subregions of the left and the right hippocampi as a function of each repetition. And what we wanted to see here was how activity changes across these repetitions, so from the first to the second to the third and then to the fourth retrieval. And what we found here was a significant decrease in activity from the first retrieval to the fourth retrieval in the bilateral anterior but not posterior hippocampi. And interestingly, these findings were not different across recent and remote memories, meaning we observed a decrease in anterior hippocampal activity as a function of repetition, irrespective of the age of the memory that was being recalled. So next, to follow up on these analyses, we wanted to see how the rest of the brain was affected by repeated retrievals. To do so, we ran a PLS analysis, which is a data-driven multivariate analytic approach that assesses the relationship between neural activity and an experimental manipulation. So essentially, what this allows us to do is to establish patterns of neural activity that are common or distinct between our 4 retrieval trials. And I'll just note here that for these analyses, we collapsed our data across recent and remote memories, given the non-significant effect of memory age that we found with our first analysis. And so with this analysis, what we were able to do was to describe patterns of neural activity that indeed dissociated as a function of repetition. So first, we found one pattern associated with the first or that initial retrieval of a memory that included activity within these canonical autobiographical memory regions, such as lateral and medial temporal lobe regions. And we see this activity depicted in the warm colors in the figure. And then we found a separate pattern that was associated with later retrievals that included more distributed activity across parietal cortices. And this pattern is depicted in the cool colors in the figure. And so together, what our data shows is that the repeated retrievals of a memory can influence the nervous support for remembering by virtue of altering the amount of constructive episodic processes that are necessary to support the retrieval of that memory. And so we speculate that this might be due to the fact that when we recall an autobiographical experience, which we have already recently thought about, meaning the details of this event have already been associated together in our mind, then that initial memory representation can be reinstated during later retrievals and thus reduce the constructive demands of the task, which will ultimately alter how the brain supports remembering. So the end. Thank you for listening. Once again, here's my email. Please feel free to send me an email if you have any questions or just want to chat some more about the work that I presented.